Greetings, everybody, and welcome to my video. Tonight, as you can see, I have completed the yellow phase of the new coil packs that I have. I got all three coils on there in their respective position in their phase. Come up pretty nice. Yeah, so I got them running. I got some weird stuff going on here. See, don't have anything in the pump. Oh, I wanted to go over the pump. If you look at this this white crystal that is formed on here, now that's pretty caked on there. That's been getting thicker and thicker. But now that it is dried completely up, it's stopped. But as long as there was moisture on here, those kept expanding up the side of the plate. So that was interesting, growing a crystal structure like that. That was pretty fun. Not much happening on the positive plate. To get some corrosion on it, but I flipped the plate over. As you can see, the top has some corrosion on it. Now the bottom has some corrosion on it. So I tried to get as much as I could out of that. And then, see, I move this there. You can see the 4-inch magnet that sits underneath there. And I see that I have a light emitting diode stuck to it. So we'll just put that over there. Okay, now we're going to look at the pump here. Very interesting. There's some more of that crystal there. You can see the crystal. You can almost see through it in some places. It's pretty clear. Now that's not the bottom of the glass. There is crystalline structure there. All the way across there. Very, very interesting. Try to get it under the light there so you can see it better. Now there's some, but you can see come out pretty cool looking. Very organic. Now there's some nickel in there. A little bit of iron from the steel. Well, the stainless steel there's a lot of nickel in there, so I'd imagine that's what that is. A lot of iron in there. Of course, there's a lot of minerals in the water, but it's very, very organic. It kind of reminds you of a ridge in the southwest eastern United States. There's ridges that look like this. Probably all over the world. I gotta go with what I know, and that's why I've been there. So, okay, I flip the plate around and look at the other side. Lots of nickel in there. A lot of iron. Very interesting. Gee, now I don't know if that's. I mean, does that look like that all come off of that plate right there? No, it doesn't. So I think there's more. Yeah, I don't know. There's a awful lot of shiny stuff in there for that plate only wearing that much. Because when I started, the plates were the same length, just as they are. See, there's no corrosion on that plate. It looks to be completely intact, other than the crystalline structure growing on it. Very little corrosion in that corner. There's a little bit of corrosion in that corner. A little bit up there. And a little bit there. Along the edge doesn't seem to be too corroded. On top or the bottom. But there's awful lot of what I was thinking was nickel in there. But I'm not so sure if that's nickel now. I'm not so sure, because there's a lot of it. And I don't think that all that come off of that, because it just doesn't look like that much material was removed from the plate. So I don't know. But it's been sitting here drying up so I could do this video. I've been waiting for it to get nice and dry. But that's an awful lot of nickel, I would say, in there. Except for the amount of material that's coming off, actually come off of the plate. Unless it spread it really thin. It must have spread it real thin. Okay, well, I'll set that back over here. Well, I've been experimenting with my new coils here. I got this one here is the red circuit, and we have a black tab here. So this is the inside, because I have two winds here. I have one wind in here going to the left and another wind going to the right. There's an inside and an outside. Okay, so the inside goes this way and the outside is that way. So there's two coils. So they're both bifilar. So there's 4 wires coming out of each one of those coils there. And I got the inside coils running in series with each other. So it comes out of the circuit, goes into one coil, comes out of one coil, goes into another coil, and then comes out of that coil, and then goes into another coil, and then back to the circuit. Okay, so you can see all these are wired in here. Okay, so that is running off of, let's see, that's coming over here to this gauge over here, and we're just about 200 milliamps there, and that is running off of this wall wart, the 12 volt 500 milliamp wall wart. And then this coil right here is a yellow coil. Same situation with those coils there. So we have the wires coming out of the coil, going in, spinning around, coming out, going into here, coming out of there, going into that coil, coming out of that coil, coming back down into this coil, going over into that coil there, the one that's along the bottom here, and into this coil, and then back out of that coil and into this circuit here. See, we can see the wires. These 2 wires here are coming out of this coil, which goes in here, and it's this bottom coil. So this is in series as well. Okay. Now this circuit I do not have attached to anything. As you can see here, there's nothing attached to. Tonight I'm using this capacitor, and I got this light cross capacitor. So all the energy from the circuits are running into this. So I got this one hooked up to here, and this one hooked up to here as well, and then that goes into this bulb. Okay, so this circuit right here is not hooked to anything on the output. And the input, I have it going into this wire. It goes through this wire. Where's it going? It's going into this. It's coming out of this. It goes into this bulb right here. And then it comes out of this bulb right here and goes right back into the circuit. So I have this bulb right here is hooked up to the output, or to the input of this Bedini circuit, and there's nothing hooked to the output of the circuit. Okay, so this is just sitting on there, spinning with that, and this light here is pulsing pretty interestingly here. Very very interesting. But I wanted to show you, if I disconnect the light here, I'll bring the light over to here. If I disconnect the light, you can see that the circuit, the amp meter will spring up. So I hope you can see. Let's see if I can get the clip off of there. Okay, so I don't know if you can see that moving really just a little bit, but when I put the light on, it goes negative. In other words, the needle goes below zero. I don't know if you can see that or not. Just a wee little bit. But the needle goes, it drops below zero. So right there is zero, nothing's running through it. I touch the light on it, and it goes negative. So the needle goes backwards, but it's just a wee little bit. I hope you can see that. Maybe I can get it to bounce. No. No, it won't do it. You have to let the energy dissipate within the meter, I guess. Or something. But I thought that was interesting. So I just have that here. I'm going to take the meter out of there. And I'll take this wire here and stick it in here. So as you can see, these two black wires here are both, those are on the input of that Bedini circuit right there. And that is the energy coming off of the Bedini circuit. Now, in the camera, it's got a pretty funky glow, but when I'm looking at it here, it's flashing really fast. But that's what the camera's picking up. And that funky throb right there. But it's flashing like a strobe light. But like I said, I guess that's all the camera can pick up. So I thought that was interesting. So basically, I got this here on here too. I forgot about this. Okay, now the outside winds. Okay, now this is the blue. These are the blue ones, so they're the outside winds in the red circuit here. I've got all of those running into these two bridge rectifiers here. Okay, one bridge rectifier is on the 29 gauge wire, and the other bridge rectifier is on a 26 gauge wire. And all three of the outside coils, all three of them, are set up in series. No, they're in parallel. I'm sorry. They're set up in parallel, and then this is my negative rail, and this is my positive rail. And I've got them running to my meter here, and they're getting 4.8 volts DC from those lines right there. So, and that's on the meter there, and those are from the 120 feet. 120 foot long coils. Now the inside coil has 147 winds. The outside coil has 132 winds. And I think one of the coils actually ended up being 133 winds. It depends on how you wind the coil. I guess I didn't wind that one as well as I did the other ones, but on average they were the outside coils were 120 or 132 winds. But on both sets of coils in there, there's 120 feet of wire. So the wire length is the same, but the turns, of course, as the coil gets bigger, it takes more wire to make a turn. So, and then we're cruising here at 600, around 600. Or a little over 600 RPMs. Now it fluctuates. We got it, it's, with 685 or around 700. It fluctuates. Now it's probably going to go back up again. Sit here and watch it for a second, because that's what it does. It goes up and down and up and down. So I haven't been able to figure out what makes that do that. So now it says it's 617, 618. Is that thing even reading right? Maybe I ought to readjust it under there. Now it's telling me I got 308 RPMs. Well, there we go. 685. Huh. I hope my RPM gauge ain't been acting up on me here. My tachometer. Must be. That's weird. Okay, well, but that's what's happening there. I got it says 4.9 volts DC coming off of these two bridge rectifiers here. I got this the funky glowing bulb here hooked to the input of this Bedini circuit with nothing on the output of the Bedini circuit. So that's all induction there. Of course, that's all induction there. And then I'm running the system off of this circuit, and from this wall wart right here. This is the 12 volt 300 milliamp wall wart. So that's running this one, and then all the energy is going into the cap. And then, of course, like I said, this one here is running this one, and all that energy is going into the cap as well. And then I got that neon there set up across. As you can see, the neon is fully lit to its full potential there. So very interesting. See, I could probably give you a disconnect the meter here and see if I can't give you a reading of what's across the, if I can get these. Nothing wants to stay. Of course not. Staying in now. And I've got 14.9 volts across the cap there, and it fluctuates as well as the motor goes up and down in speed. Now it's telling me I'm at 315 RPMs, which that sounds about right, because that's not spinning very fast. It's spinning really slow. Really slow. There's an inside look at the coil there. As you can see, there's the blue coil is at the top, and the black coil comes out of the bottom there. And it's the same way with that in there. I don't know if you can get that light up in there. You can see it. But they're stacked in there. There's one that comes out of the bottom, one that comes out of the top. I don't know. Let's see that in there. If I can, yeah, there you go. There, you can see the wires there. Okay. So that's how I wound those coils, and it's very interesting. Doing some experiments here, and I still gotta wind the green phase. Working on that. My coil winder doesn't work exactly the way I wanted it to, so it's not easy to wind a coil. Of course, it's better than doing it by hand, I guess, but I'm kind of doing it by hand anyway, so I just don't have to hold it. I still got to wind it by hand because that drill makes it spin way fast. But the drill acts as a brake, so when I'm winding the coil and I stop, the coil doesn't want to unwind or anything, because the drill keeps it in place, holds it there. It's all holds it, steady for me while I do other things, kind of hands free. But that's what I've been playing with here, and I've been actually playing with this for a couple days now. I had these I had these in parallel and then in series, and the same with the circuits in parallel and in series and stuff. And then when I hooked this up this evening and got this throbbing bulb here off of the input of this Bedini circuit with nothing hooked up to the output or anything, it's just these wires right here go right to that. So that is coming from the input of the one Bedini circuit, and then all of the outer coils on the red circuits are in parallel here. And what do I have that? Oh, I had that running to something. Oh, I had that running to the meter and I moved it. So I can hook the meter back up to it here. There, and we're looking at 5 volts across there with all that. And so there's an induced 5 volts of current right there, and then here's an induced current through this LED, and I believe that's a 12 volt LED bulb, and so is that one, is also a 12 volt LED bulb. And that's what the motor's been running at. The one circuit is running at 200 milliamps, and the other circuit is running at 100 milliamps. And I have the same resistance, 300. Actually, it's 325 ohms, because those are 325 ohm resistors. They're marked 330 on the package, but they're only 325. So that's what it's running on. So I'm finding that the inner coil, I was trying to dial it in. It depends on what you do with the coils. Doing something like this with the outer coils while the inner coils are driving it will give you an input like that, so it kicks it up 100 milliamps, as opposed to this one where it's running through here, and then the outer circuits I just got bucking back out to this light right here. Now if I disconnect this light, the wheel will speed up, so I'm going to go ahead and disconnect the light, and we can watch the wheel, the RPMs go up. So there is voltage being induced in the coil, which is slowing down the rotor, but it's speeding up pretty good now. So if I hook the light back up again, so now I got it hooked back up again, and we see the rotor slow, it'll slow back down to where it was roughly before, around 320, 318. And our induced voltage went up as the RPM went up also. But I got the strobe light going, so as you can see here, it'll begin to drop down slowly. So well, there's the pump. Very organic. Kind of a structure there. A lot of crystal formation there. Unless I got it backwards, I'm wrong, but a lot of crystal formation there, and some crystal formation there. As you can see, how it like just kind of grew. Very interesting. Very interesting. Well, that's 25 minutes. I think that's long enough for a video. I hope you enjoyed the video. Have a wonderful day. Peace.